Okay, here is lesson 2.1.5, the last lesson here in section 2.1, and we're going to take a deeper look into some of the angle relationships we've been discovering here in 2.1. Remember, some of those relationships and the ones they're going to focus on today are same side interior, alternate interior, corresponding angles, and there are quite a few more. All right, so make sure that when you're in class with me, you take a look at that board, you write down those vocab words, and you start practicing those vocab words, okay? So we'll get started here in the video guide. Just looking at this diagram, what is the sum of x and y? Well, x and y are that same side interior relationship there, same side of the transversal inside the parallel lines, and we should know something about same side interior angles, what they add up to, or whether maybe they're equal, all right? And if we don't know, all right, make sure we ask, because this one we should know, it's just part of our vocab. Now, basing it off that problem, we have Rihanna exclaiming, I think something is wrong with this diagram, okay? And what we can see is her same side interior angles here, one is 100 and one is 80, but it looks like we don't have parallel lines getting intersected by a transversal here. So I think that's what she's referring to, but write it in your own words, like what looks wrong, why does this diagram not work, okay? Now we move on, and it's the same kind of diagram, but we can actually see this point of intersection where it didn't quite get there, but now we can see this point of intersection. So Maria in the last problem was not convinced that these must be parallel, that lines must be parallel for this relationship to exist. So we're going to take a look. And it says, why must the lines intersect in Maria's diagram? I don't really love that question, so I'm going to help you out here. Okay? They must intersect because it says right here, they are not parallel. Okay? So it says they are not parallel, which means they must intersect. Okay, so I'm giving you that one because I don't really love that question. But really right there, if two lines are not parallel, they're going to intersect. Okay? So, and then it's going to ask us, what is the measure of BED, this angle down here? We got to use the Triangle Sum Theorem and explain what that tells us about AB and BC. Now, this question, again, this is one I don't really like, so I'm going to help you out here. If the angle measures at point A, so it's 100, and point C is 80, could AB and CD intersect at a point somewhere on the other side? So somewhere on the left side here, okay? And what we'll see will kind of connect from what the last two problems were in B and A, but the answer here would be no. They will not intersect, okay? Because really we have here, if these lines are going to intersect, you're going to form a triangle, like we see here. Or even if it was on the left side, okay, it would form a triangle. And a triangle has 180 degrees in it, and that 180 degrees is already taken up by our angles right here. Or if we put them on the other side, it would still be 180 because of supplementary relationship. And so you have these angles taking up all 180 degrees, which means there is no degrees left to form a triangle. Okay, so they will not intersect. They shouldn't intersect over here, and they shouldn't intersect on the left side either. Okay. Now, we're going to kind of use this relationship, this idea that, well, if these equal 180 degrees, we shouldn't see these intersections because we shouldn't be able to form a triangle then if all 180 degrees are taking up in this relationship, this same side interior relationship. And so we're going to use that idea here, and it says, in this diagram, FG and HI, must they be parallel? Well, do they add up to 180 degrees? If they do, then yes, they must be parallel because there's no more degrees for them to intersect. Or there is no possible way that these two lines will intersect if they add up to 180 degrees here. Okay? And then you just write a theorem based on your conclusion, and you can say if ... then ... all right? And you need to fill in that ... If we see this type of relationship, which this relationship has a name, then we see this parallel relationship. Okay? So fill it in with your own words, an if-then theorem based on what we're seeing here. Okay? Now, we want to use that theorem that you just wrote, that if-then theorem, and say, well, are these lines going to be parallel here? And then you can say, well, I think they're going to be parallel based on the theorem I just wrote, or I don't think they're going to be parallel based on the theorem I just wrote. Okay, same kind of thing here. Are these lines here based on the theorem that we wrote in the beginning? Is that going to be parallel? Does it have that relationship there? If it does, you say, yes, this is going to be parallel because of the relationship or the theorem that we wrote in 248. If you still don't think it's going to be parallel, then you would say, no, I don't think it's going to be because it breaks the theorem we wrote in 248. And then lastly, we take a look at 8 and 9. We see that these were corresponding. We see that these are alternate interior angles. And we can write two more theorems. If corresponding angles are congruent, then you fill in the blank. And the other theorem is if the measures of alternate interior angles are congruent, then we fill in the blank. Okay? And just look what's happening here. You'll be able to draw these conclusions, these theorems based on these problems right here. Okay? And then the last one is just how did you feel about the lesson, and write any questions you have in the box. Or two, if you have questions in the box, and or if you want to email me questions about the lesson, please do so.